Bismillah ar-Rahman ar-Rahim. Today we shall discuss about atoms and molecules. It is lecture number 17 and this is subject of general science. Today the outlines are, first of all, introduction about the main topic. Then we will discuss about what is atom. Then law of conservation of mass. Then Dalton's atomic theory. Characteristics of atom. And molecules and atomicity of molecules. First of all, father of modern chemistry, Antoine L. Lavoisier. Antoine Laurent de Lavoisier, 26 August 1743 to 8th May 1794. He was a French nobleman and chemist central to the 18th century chemical revolutions and a large influence on both histories of chemistry and biology. Antoine L. Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combinations. He determined that oxygen was the key substance in combustions, and he gave the element its name. He developed the modern system of naming chemical substances and has been called the father of modern chemistry for his emphasis on careful experimentations. After the French revolutions, he was a French nobleman and chemist. It is generally accepted that Lavoisier's great accomplishment in chemistry stem largely from the changing the science from a qualitative to the quantitative one. Lavoisier is most noted for his discovery of the role oxygen plays in combustions. He recognized and named oxygen and hydrogen and opposed the phlogiston theory. Lavoisier helped construct the metric system, wrote the first extensive list of elements, and helped to reform chemical nomenclature. He predicted the existence of silicon and discovered that although matter may change its form or shape, its mass always remains the same. Lavoisier was a powerful member of a number of aristocratic councils and an administrator of the Firm General. The Firm General was one of the most hated components of the ancient regime because of the profits it took at the expense of the state, the secrecy of the terms of its contracts, and the violence of its armed agents. All of these political and economic activities enabled him to fund his scientific research. At the height of French Revolution, he was charged with tax fraud and selling adulterated tobacco. That was collusion. He described the law of chemical combinations. So there are two laws of chemical combinations: law of conservation of mass and law of constant proportions. And if we see the law of chemical combinations, so the law of chemical combinations describe the basic principles obeyed by interacting atoms and molecules. Interactions that can include many different combinations that happens in many different ways. So this amazing diversity of interactions allow for an astounding variety of chemical reactions and compounds. Spontaneous chemical reactions happen constantly, shaping the world around us, while human engineers specific reactions to our benefits and attempt to curb reactions that hurt us. Though chemical reactions can be as complex as they are numerous. So they are all fundamentally governed by these same guiding laws of chemical combinations, which lays the groundwork for analysis of chemical reactions. So they give a mathematical formulations and allow predictability given initial conditions. So they are the launch pad from which we jump off to creating all sorts of wild components and phenomena. And while chemistry is still difficult and intricate, so with the laws of chemical combinations on our side, we can begin to make some headway. So as we have discussed that there are two laws of chemical combinations, the law of conservation of mass and the laws of constant proportions. First of all, we see that what is the law of conservation of mass. The law of conservation of mass states that the net change in mass of the reactants and products before and after a chemical reaction is zero. So this means that mass can neither be created nor destroyed. In other words, the total mass in a chemical reactions remain constant. So this law was formulated by Antoine Lavoisier in 1789. It was later found to be slightly inaccurate, as in the course of chemical reactions, mass can interconvert with heat and bond energy. However, these losses are very small, several orders of magnitude smaller than the mass of the reactants, so that this law is an excellent approximation. Antoine Lavoisier, a French scientist, established a theory of law of conservation of mass. The law of conservation of mass states that mass can neither be created nor destroyed in a chemical reactions. The second law is that is law of constant proportions. Law of constant proportions states that a chemical compound always contains exactly the same proportions of elements by mass. The law of constant proportions states that when a compound is broken, the masses of the constituent elements remain in the same proportions. Or in a chemical compounds, the chemicals are always present in definite proportions by mass. So this means each compound has the same elements in the same proportions, regardless of where the compound was obtained, who prepared it, or its mass. So this law was formulated and proven by Joseph Louis Proust in 1799. This law is also known as law of definite proportions. Joseph Louis Proust gave this law, hence this law is also known as Proust laws. Then John Dalton. John Dalton, his date is from 6 September 1766 to 27 July 1844. He was an English chemist, physicist, and meteorologist. He is best known for introducing the atomic theory into chemistry and for his research into color blindness, sometimes referred to as Daltonism in his honor. John Dalton, as I have discussed, that this is Uh, Duration of his life is from 6 September 1766 to 27 July 1844. So he was an English chemist, meteorologist, and physicist. So he is best known for his formulae work in the development of modern atomic theory and his research into color blindness. If we talk more about his scientific work, so Dalton early life was influenced by the prominent Quaker Elihu Robinson, a competent meteorologist and instrument maker from Eaglesfield, Cumbria, who interested him in problems of mathematics and meteorology. During his years in Kendall, Dalton contributed solutions to problems and answered questions on various subjects in the Lady's Diary and the Gentleman's Diary. In 1787, at age 21, he began his meteorological diary, in which during the succeeding 57 years he entered more than 2 lakh observations. He rediscovered George Hadley's theory of atmospheric circulations, now known as the Hadley cells. Around this time, and in 1793, Dalton's first publication, Meteorological Observations and Essays, contained the seeds of several of his later discoveries, but despite the originality of his treatment, little attention was paid to them by other scholars. So, a second work by Dalton, Elements of English Grammar, or a new system of grammatical instruction for the use of schools and academies, was published in 1801. After having the Lake District, Dalton returned annually to spend his holidays studying meteorology, something which involved a lot of hill walking until the advent of aeroplanes and weather balloons. The only way to make measurements of temperature and humidity at altitude was to climb a mountain. So Dalton estimated the height using barometers. The Ordnance Survey didn't publish map for the Lake District until the 1860s. So before then, Dalton was one of the few authorities on the heights of the region's mountains. So he was often accompanied by Jonathan Otley, who also made a study of the heights of local peaks, using Dalton's figures as a comparisons to check his work. Otley published his information in his map of 1818. Otley became both an assistant and a friend to Dalton. Then there are some main points of Dalton atomic theory. The most important of all Dalton's investigations are concerned with atomic theory in chemistry. While this name is inseparably associated with the theory, the origin of Dalton's atomic theory is not fully understood. The theory may have been suggested to him either by researchers on ethylene and methane, or by analysis of nitrous oxide and nitrogen dioxide, both views resting on the authority of Thomas. Elements are made of extremely small particles called atoms. And the second point about S theory is atoms of given elements are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. Atoms cannot be subdivided, created, or destroyed. Atoms of different elements combine in simple whole number ratios to form chemical compounds. In chemical reactions, atoms are combined, separated, or rearranged. Now, what is an atom? The question is that what is an atom? So, atom consists of nucleus made of protons and neutrons orbited by electrons. So, we now know that atoms are made up of three particles: protons, neutrons, and electrons. So, which are composed of even smaller particles such as quarks. Atoms can be defined as the smallest particle of matter that takes part in a chemical reactions. How big are atoms? An atom is the smallest unit of ordinary matter that forms a chemical element. Every solid, liquid, gas, and plasma is composed of neutral or ionized atoms. Atoms are extremely small, typically around 100 picometers across. They are so small that accurately predicting their behavior using classical physics as if they were tennis balls, for example, is not possible due to quantum effects. So every atom is composed of a nucleus and one or more electrons bound to the nucleus, and the nucleus is made up of one or more protons and a number of neutrons. Only the most common variety of hydrogen has no neutrons. So more than 99.94% of an atom's mass is in the nucleus. The protons have positive electric charge and the electrons have a negative electric charge, and the neutrons have no electric charge. If the number of protons and electrons are equal, then the atom is electrically neutral. If an atom has more or fewer electrons than protons, then it has an overall negative or positive charge, respectively. Such atoms are called ions. The electrons of an atom are attracted to the protons in an atomic nucleus by the electromagnetic force. The protons and neutrons in the nucleus are attracted to each other by the nuclear force. So this force is usually stronger than the electromagnetic force that repels the positively charged protons from one another. So under certain circumstances, the repelling electromagnetic force becomes stronger than the nuclear force. So in this case, the nuclear splits and leave behind different elements. So this is a form of nuclear decay. So atoms are very small. They are smaller than anything that we can imagine or compare with. So now there are some characteristics of atoms. What are those characteristics? Like the first one is atom is the smallest particle of matter. All elements are made up of teeny particles called atoms. Atoms are very small in size and cannot be seen through naked eyes. Atoms doesn't exist in free state in nature, but atoms takes part in the chemical reactions. The properties of matters depend upon the characteristics of atoms. Atoms are the building blocks of an element similar to a brick which combines together to make a building. The size of atom is indicated by its radius. In ancient time, atoms was considered indivisible. Now there are symbols of atoms of different elements. Symbol of some elements are formed from the first letter of the name and a letter appearing later in the name. For example, chlorine, the symbol for chlorine is Cl. For zinc, that is Zn, etc. So some have been taken from the name of elements in Latin, German and Greek. For example, iron is Fe from ferrum, sodium is Na from natrium, potassium is K from kalium. Now, what is atomic mass? Mass of an atom is called atomic mass. Since atoms are very small, consequently actual mass of an atom is very small. For example, the actual mass of one atom of hydrogen is equal to 1.673 into 10 raised to power minus 24 gram, and this is equal to 0.0000 and so on 1673 gram. So to deal with such small number is very difficult. So thus for convenience relative atomic mass is used. Then what is molecule? A molecule is a group of two or more atoms that are chemically bonded together, that is tightly held together by attractive force. Then atomicity of molecules. Monoatomic. When molecule is formed by the single atom only, so it is called monoatomic molecule. Generally noble gases from monoatomic molecules, for example helium, He, neon, Ne. Then diatomic, when molecule is formed by the combination of two atoms of it is called diatomic molecules, for example hydrogen, oxygen, nitrogen, chlorine. Then triatomic, when molecule is formed by the combination of three atoms, it is called triatomic molecules, for example molecule of. Then tetratomic, when molecule is formed by the combination of four atoms, that is called tetra, so atomic molecules, for example phosphorus molecules. Then polyatomic, when molecule is formed by the combination of more than two atoms, so it is called polyatomic molecules, for example sulfur molecules. So all metals are monoatomic, all gases are diatomic. Then molecules of different elements, like molecules of an element, are constituted by the same type of atoms. For example, oxygen plus oxygen becomes oxygen gas, O2, and diatomic O plus O plus O, then it becomes O3, ozone. Then 4p to p4, the phosphorus, tetratomic, 8s2, s8, sulfur. How ions? What are ions? Particles carrying positive or negative charge are called ions. And there are some types like cations, positively charged ions, and anions, negatively charged ions. And all metals form cations by losing electrons. And all non-metals form anions by gaining electrons. Then chemical formula is there. Chemical formula of the compound is symbolic representation of its composition. For example, H2O, that is water, CaO for calcium oxide, NH3 for ammonia, K2SO4 is potassium sulfate. Then there is concept of writing chemical formula. The valencies of our charge on an ion must balance. So when a compound consists of metal and non-metal, the name or symbol of the metal is written first. For example, calcium oxide CaO, sodium chloride NaCl, iron sulfide FeS, copper oxide CuO. So when oxygen, chlorine, sulfur are non-metal and are written on the right, it is calcium, sodium, iron and copper are metals and are written on the left. In compound formed with polyatomic ions, the ions is enclosed in a bracket before writing the number to indicate the ratio. So what is the concept of mole? 1 mole of any species, like atoms, molecules, or particles, is that quantity, a number having a mass equal to its atomic or molecular mass in grams. 1 mole of anything, that is equal to 6.022 into 10 raised to power 23 number. And mass of 1 mole of particular substance is solved. Then Avogadro's numbers. It was named after the Italian scientist named M.Ed Avogadro. and it's denoted by its value is 6.022 in 10 to the power 23. So A naught is equal to 1 mole. So this was all about this lecture. Allah Hafiz.